Giants of celestial vision. The world's largest radio telescopes. Humanity has always strived to understand the mysteries of the universe. From simple observations of the stars with the naked eye to the use of the most complex modern technologies, we are constantly expanding the boundaries of our understanding of space. One of the most important tools in this endeavor is radio telescopes, devices capable of capturing radio waves emanating from cosmic objects. These signals, invisible to the human eye, carry invaluable information about the processes occurring in the most remote corners of the universe. In this video, we will take a journey into the world of giant radio telescopes, examine their structure, principles of operation, history of development, and, of course, get acquainted with the most impressive representatives of this class of astronomical instruments. History of radio astronomy. The history of radio astronomy began in the 1930s with the work of Carl Jansky, who discovered radio emission from the center of the Milky Way. This discovery marked the beginning of a new era in the study of space. The first radio telescopes were quite simple, but with the development of technology, they became increasingly complex and powerful. An important milestone was the invention of radio interferometry in the 1940s, which significantly increased the resolution of observations. How radio telescopes work. Unlike optical telescopes, which collect visible light, radio telescopes capture electromagnetic radiation in the radio range. Radio waves, like light, are part of the electromagnetic spectrum, but have a much longer wavelength, from millimeters to tens of meters. This allows them to penetrate cosmic dust and gas, which are opaque to visible light, opening up for study objects hidden from optical observations, such as galactic centers, star-forming regions, and supernova remnants. The main components of a radio telescope are: antenna, or radio mirror, serves to receive radio waves. The shape of the antenna is usually a parabolic surface, in the case of reflector telescopes, which focuses the received signals at one point, the focus. The size and shape of the antenna directly affect the sensitivity and resolution of the telescope. Feed horn. Located at the focus of the antenna and receives the focused radio waves. It converts electromagnetic radiation into an electrical signal. Radiometer. Amplifies the weak radio signals coming from the feed horn and converts them into electrical impulses suitable for further processing. Modern radiometers have extremely high sensitivity and can register very weak signals. Data processing system. Includes analog to digital converters, ADCs, computers, and specialized software. It is responsible for digitizing, processing, analyzing, and visualizing the obtained data. Creating radio images, constructing spectra, and other types of analysis are carried out here. The principle of operation of a radio telescope is similar to the principle of operation of a conventional satellite dish, but the scale, accuracy, and sensitivity are much higher. Types of radio telescopes. There are several main types of radio telescopes. Reflector radio telescopes use a parabolic radio mirror to focus radio waves. This is the most common type of radio telescope. They can be fully steerable, capable of pointing at any point in the sky, or transit, observing only in the plane of the meridian. Interferometers consist of several separate radio telescopes, or antennas, working together. Signals from each telescope are combined using special electronic equipment, a correlator. This allows achieving a much higher angular resolution, equivalent to the resolution of a telescope with a diameter equal to the distance between the most distant antennas, the baseline of the interferometer. Very long baseline interferometry, VLBI, allows achieving extremely high resolution and is used for precise determination of the coordinates of cosmic objects, studying the structure of quasars, and other tasks. Antenna arrays represent a multitude of small antennas located on a certain area. Signals from all antennas are summed, which increases the sensitivity and field of view of the telescope. An example is the low-frequency array, LOFAR. The largest radio telescopes in the world. Now let's get acquainted with the largest and most powerful radio telescopes created by mankind. FAST, 500-meter aperture spherical telescope, located in Guizhou Province, China. It is the world's largest filled aperture radio telescope. The diameter of its spherical radio mirror is 500 meters. FAST's unique design with an active surface allows changing the shape of the reflector to compensate for spherical aberration and improve signal reception quality. FAST is used to search for pulsars, study the interstellar medium, search for extraterrestrial civilizations, SETI project, study fast radio bursts, FRB, and other astronomical research. Radon 600, radio telescope of the Academy of Sciences, located in Karachay-Cherkessia, Russia. It is one of the largest radio telescopes in the world. Its ring antenna with a diameter of 576 meters consists of 895 reflecting elements. Radon 600 has a unique ability to simultaneously observe in a wide frequency range. It is used to study the Sun, galaxies, radio sources, as well as for solving problems of space geodesy. Effelsberg, 100-meter radio telescope, located in Germany. The diameter of its parabolic radio mirror is 100 meters. Before the commissioning of FAST, it was the largest fully steerable radio telescope in the world. Effelsberg is used for a wide range of radio astronomical research, including the study of pulsars, the interstellar medium, galaxies, masers, and other objects. Green Bank Telescope, GBT, located in the USA. It is the world's largest fully steerable radio telescope. The diameter of its parabolic radio mirror is 100 meters. GBT has high sensitivity and is used to study the weakest radio signals from space, including research in radiochemistry and the search for organic molecules in space. SKA, Square Kilometer Array, is a currently under construction international project that will become the world's largest radio telescope. SKA will consist of thousands of antennas located in Australia and South Africa. The total radio wave collection area will be about 1 square kilometer. SKA will allow conducting unprecedented in scale and accuracy radio astronomical research, including the study of the first stars and galaxies, cosmic magnetism, pulsars, and gravitational waves. The importance of radio telescopes for science. Radio telescopes play a huge role in modern astronomy and cosmology. They allow studying objects invisible in the optical range, such as radio galaxies, e.g., Centaurus A, quasars, e.g., 3C273, and pulsars, e.g., the pulsar in the Crab Nebula. Exploring the interstellar medium, consisting of gas and dust, studying the processes of star formation and galaxy evolution. Studying the cosmic microwave background, relic radiation left over from the Big Bang, which allows obtaining information about the early universe. Searching for extraterrestrial civilizations within the SETI project. Conducting research in the field of space navigation and communication.